Hello everyone, hope you are doing well. In this video, I will explain about how to route traffic from AWS application load balancer to AWS ECS Fargate or AWS ECS Service. In this video, I am approaching based on monolithic approach and microservice approach. So, for better understanding, I will write some bullet points about load balancer. First point, load balancing. What is load balancing? We need to understand. Load balancing is nothing but route incoming traffic to appropriate microservices or monolithic application. It is nothing but load balancing. Like one incoming traffic it will be coming, that we can route the different services based on target groups, path patterns. It's nothing but load balancing. I am repeating one more time. Route incoming traffic to appropriate microservices or monolithic application is called load balancing. Load balancing. Second point, types of load balancers in AWS. So we need to know what are the types of load balancers are available in AWS. Types of load balancers in AWS. First one, application load balancer. Application load balancer. Application load balancer used for routing HTTP plus HTTPS traffic with context based routing. Here, first one, types of load balancers in AWS. Application load balancer. This application load balancer works based on the HTTP, HTTPS. These two protocols. Application load balancer used for routing HTTP, HTTPS traffic with content based routing. Content based routing, nothing but like if we are using monolithic, we can route. It is monolithic is nothing but single application, right? By using target group, single target group, we can route the traffic. But if we are using microservices, then we need to route traffic based on the target groups and path pattern, like controller path, method level paths are there, right? Based on those paths, we need to route the traffic. So important point, application load balancer works with HTTP/HTTPS. Remember this point. Second one, network load balancer. Network load balancer. So change to black color. Use for handling. Use for handling TCP/UDP. TCP/UDP traffic with high performance, and low latency. High performance and low latency. Here, network load balancer used for handling TCP UDP. TCP UDP. Based on these protocols, TCP UDP, it will work the network load balancer used for handling TCP UDP traffic with high performance and low latency. Next one, third. Next one, gateway load balancer. Gateway load balancer. Gateway load balancer. So this gateway load balancer used for interacting with third party virtual appliances with a transparent gateway. The gateway load balancer used for interacting with third party virtual appliances with a transparent gateway. So another one, the classic load balancer. It is available in older versions, but newer versions This is one not there, so I am not discussing. It is like a old or outdated. See, load balancing. This is the load balancing. Route. What is load balancing? Route incoming traffic to appropriate microservices or monolithic application. It will route the traffic. So request coming from the browser, load balancer will receive the request. After that, based on the port and path, it will route the traffic to the appropriate service. Is called load balancing. Types of load balancers in Java. There are four, but currently available three. Application load balancer, network load balancer, gateway load balancer. Application load balancer used for routing HTTPS traffic with content-based routing. So these are the protocols. Application load balancer uses these two protocols, either HTTP or HTTPS, and traffic with content-based routing. If single application, then if it is suppose if it is a monolithic application, then one target group is sufficient. But if it is microservices, independent services are there, then we need to use target group plus path pattern. Path pattern is nothing but content based routing, like API slash employee student, like that. So network load balancer used for handling TCP UDP traffic with high performance and low latency. Gateway load balancer used for interacting with third party virtual appliances with a transport transport gateway. Then tell me which load balancer we need to choose. So think once, tell me which load balancer we need to choose. So we need to choose application load balancer. We are mostly working on HTTP, HTTPS, right? These two protocols we are mostly working. Suppose we are writing, for example, we are writing like, suppose example, HTTP colon double slash some IP address, IP colon some port, suppose some port slash some student, suppose all these are like that. So what is HTTP? So it is a this protocol supported by application load balancer. If you are accessing through a gateway endpoint, then it is HTTPS. HTTPS also supported by application load balancer. So we need to choose application load balancer. Let's try to understand what is application load balancer. What is application load balancer? So let's try to understand what is application load balancer. Application load balancer. Application load balancer. So what is application load balancer? AWS application load balancer routes routes incoming traffic to the appro, appropriate ECS service or forget 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 micro services based on target groups are routing rules routing rules are conditions routing rules are conditions conditions. Example path pattern, based on path pattern. Here AWS application load balancer routes incoming traffic to the appropriate AWS forget containers. So in easy, this forget is nothing but serverless computing, right? So by using AWS ECR elastic container registry, we are in elastic container service, we are pushing the in AWS elastic container registry, we are storing the Docker images. After that, we are linking with the AWS ECS task definition, right? In task definitions are managed by service, right? These are the under there in cluster. So it is Fargate is a runs the containers, nothing but microservices, runs the microservices. Every load balancer is nothing but incoming traffic will be coming. We are wrote the appropriate microservices based on the like target groups, path patterns, etc. What is application load balancer? AWS application load balancer routes incoming traffic to the appropriate, easy to forget. You can mention like instances or containers. Forget containers. Forget containers are microservices based on target groups, routing rules, conditions, etc. 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 Example path pattern. So I'm repeating one more time. Application load balancer AWS application load balancer routes incoming traffic to the appropriate ECS Fargate containers. Nothing but microservices or monolithic application. You can also mention monolithic application. Monolithic application. Application load balancer. It is very important. Listen. Application load balancer. AWS application load balancer routes incoming traffic to the appropriate ECS Fargate containers. Containers are nothing but each container we are storing on Docker image. Docker image contains one application, one microservice, microservices. Nothing but microservices are monolithic application based on target groups are routing rules. Routing rules are nothing but some conditions, etc. So this is the one of the example of routing rules or conditions. Application load balancer. AWS application load balancer routes incoming traffic to the appropriate ECS Fargate containers, nothing but microservices. Or if single container is nothing but monolithic application based on target groups or routing rules. Routing rules, nothing but conditions, etc. It will route the traffic from application load balancer to appropriate services, right? If a monolithic application, then single target group is sufficient. Without routing rules, listeners, we can interact with single microservice. In this video, I will show with a single target group. So fourth point here, application load balancer. This is important, so I'm repeating one more time. Application load balancer. AWS application load balancer routes incoming traffic to the appropriate ECS Fargate containers. Fargate is a serverless computing. It will run the containers. Nothing but microservices. Each container can store one microservice in the form of Docker image or monolithic application. So if single container is there, is nothing but monolithic application. If single container is there, it is nothing but monolithic application based on target groups or routing rules. Routing rules slash conditions. Routing rules and conditions both are same, etc. It will route the traffic from ALB to appropriate microservice or monolithic service. If monolithic service only there, single service, then we can access by using target group, single target group. If multiple services are there, we need target groups, multiple target groups plus routing rules. Routing rules, nothing but path pattern. Each microservice contains class level path, method level path, right? Based on those, it will route the appropriate microservices. Target group is nothing but each microservice running on one port number, right? That is called a target group. So host Spring Boot application, we are port mapping to container port, right? So we need to mention here in target group that container port we need to mention. I will explain more elaborate in coming points. I will explain more about it. Now, routing rules, conditions. We need to understand what is routing rules and conditions. So, point number A, using application load balancer, target group using application load balancer target group. If single application is there, then we can use application. Suppose one load balancer is there, it will route traffic to one single microservice or one monolithic application, then we can use target group. So using ALB target group, we can route the traffic by using target group if one service is only there, single service is there. Routing rules slash routing rules with listener. Routing rules with listener. Rules slash conditions and target groups microservices. I will explain this point here. Routing rules conditions using ALB target group. If monolithic application is there, it is running on single port, it is a single application running on single port, then we can use single target group to route the traffic. So ALB routes routes traffic with listener service tasks configured as target target group target group routes ALB routes traffic traffic to ALB routes traffic to ECS service task configured as target group routing rules conditions. This is the point number A. Using application load balancer target groups. If monolithic application, so we need to go for single target group application load balancer routes traffic easier service task configured as target group ALB routes traffic to ECS elastic container service task configured as target group. Next, routing rules with listener rules. Listener rules nothing but conditions and target groups. Based on the path pattern and target groups, we can communicate with microservices. If multiple services are there, based on the target groups and path patterns, routing rules, listeners nothing but path patterns, we can communicate, right? So yeah, application load balancer routes traffic based on host name, comma URL path, URL nothing but path pattern, URL paths using listener rules, etc. Here, if microservices are there, then application load balancer routes traffic based on host name nothing but www.com. This is host name, URL paths using listener rules, etc. Multiple ways to, if microservices are there, as per our requirement, we can route the traffic from application load balancer to appropriate microservice, like based on target groups along with. So ALB route traffic based on target groups along with host name, comma URL paths, listener rules, etc. URL paths using listener rules, etc. These are the routing rules. Conditions are most important, etc. Some more are there, so I am not discussing. Routing rules conditions using ALB target group. If single service is there, then we can go for single target group without any path patterns. ALB route traffic easier service task configured as target group. Routing rules with listener rules conditions. Listener rules is nothing but conditions only. And target groups. Remember Tamil monolithic application. If single application, then create one target group without any path patterns. It will work. If single application, then create one target group without any path patterns, it will work. This target group configured to application load balancer. Suppose here routing rules with listener rules conditions based on target groups. If microservices are there, then each microservice create one target group along with conditions. In next point, I will explain what are the conditions are there. Fifth point, here router rules slash conditions. Here, what are the conditions are there? Host header by using target group plus these rules, right? If multiple microservices are there, say each microservice create one target group and along with conditions. These are the conditions. So host header condition nothing but we have a target group and host header based on to we can route traffic to appropriate microservice or path based on the path, like class level path, method level paths are there, right? Based on the path, we can route the incoming traffic to appropriate microservice. HTTP request method like get method, post method, etc. Based on the path type, based on the request method type also, we can route the traffic. HTTP request method. So next one, HTTP request method. By using HTTP request method also, we can route the traffic. After that, source IP. By using source IP as well, we can route the traffic application load balancer to appropriate microservice. In this video, practicals also I will do. I will explain these. These are the, I will show where these are the available routing rules conditions. Those are next HTTP headers. By using target group plus HTTP headers, we can route the traffic. We can route the traffic from application load balancer to appropriate microservice. After that, query string. Next, here these are the routing rules or conditions. So routing rules, it will work like target groups, target group plus condition. If microservices projects are there, multiple microservices are there, then we are routing traffic based on these conditions, like host header, path, mostly path only mostly used, host header, path, HTTP request method, source IP, HTTP address, query string. So 6.6, we need to know the default ports for HTTP and HTTPS. We need to know what are the default ports for HTTP and HTTPS. For HTTP, port is for HTTP. So here HTTP port 80. So for HTTPS colon default port is 443. 7 point. Here this is most important. The default ports for HTTP and HTTPS are. So for HTTP port is 80. For HTTPS port is 443. So at application load balancer level we are using 80. Then we can access like HTTP colon / some URL something like .com without port number, like without port number 80 we can access. So I will use at the application load balancer level 80 port. So without port, we can access our application. I will show the default ports for HTTP and HTTP SR. If we are configuring default port, then no need to mention. While we are accessing the endpoint, no need to mention this port number. For HTTP, default port is 80. For HTTPS, default port is 443. Remember, this is most important. After that, 7 point, port mapping. 7 point is port mapping. See, observe our Spring Boot project. This is the welcome app, right? It is running on 8080. So here Spring Boot running on 8080, right? Default Tomcat port number 8080 is a default Tomcat port number, right? Our Spring Boot application running on 8080. It is a default Tomcat port number. So 8 point, we are port mapped to container port colon Spring Boot application port. So here we are port map to container port colon Spring Boot application port. Why we need to port map? Like after we are developed one Spring Boot application, it is running on Tomcat, but it is running on 8080 port number. After while converting we are converted Docker image by using Docker build. First we are by using Docker build -t. We are build a Docker image. We want to run the Docker image, Docker image, nothing but our Spring Boot application. Then we need to port map to container port. So application, our Spring Boot application port is different, container port is different. So we need to port map, right? For example, Docker run -d means detached state port mapping. If you are using capital P, this is dynamic port mapping. So I am not using, so it will be static one. Our choice ports 8080 colon 8080. After that, we need to mention username class image name. Suppose welcome app, right? Welcome -app colon latest. For images, some rules are there. Must be small letters. Use only symbol only use. Some of the symbols are not allowed. See, we are port mapper to container port colon Spring Boot application port. So if you want to run our application on Docker, then we need to port map application port and container port. For example, Docker run -d means detached, -p means port mapping. This is the container port application port. 8080 is the application port. We are mapping to same. So this is the username. If it is AWS ECS, if it is AWS ECR, then ECR name. This is the image name. This is the tag. So 9 point. So 9 point routing traffic based on target group. How this will be work? Routing traffic based on target group. Here ALB listening on port colon. Suppose ALB is listening on default port. What is the default port of HTTP? It is the 80 and colon target target group forwards traffic to ECS forget you can mention suppose container here routing traffic based on target group for example. So application load balancer running on 80. I want to forward traffic to ECS Fargate container for some application in container, one Spring Boot application. Suppose microservice. I want to otherwise Spring Boot application routing traffic based on target group. ALB listening on port. Suppose one request is coming from the some user customer through browser. One request is coming to application load balancer. So on port 8080 is the default port of HTTP. So then target group forward traffic to ECS Fargate appropriate container. In this container Spring Boot application available in this in this container suppose microservices slash monolithic application available. See routing traffic based on target group. Routing traffic based on target group. Application load balancer listening port on port 80. Target group forward traffic to ECS forget appropriate container. This forget is the serverless computing. It will run the container, right? This is container. So forward traffic to ECS forget. It is nothing but it will run the containers. Appropriate container. This is a container. Nothing but microservice. One independent service will be there, either microservice or monolithic. Otherwise, nothing but one application. Monolithic or microservices or monolithic application available. Okay. Example port mapping. So it is I decided to use application load balancer port 80. It is a default port for HTTP. So while accessing, no need to enter this port number, and this is the target group port number. If multiple microservices are there, then we need to enable routing rules like path pattern kind of path pattern we need to add path. If it is my single service, then This is the application load balancer port, listening port, and target port sufficient. If it is multiple services are there, then we need to add either path patterns here, multiple are there, right? Either host header, path, HTTP request method, source IP, HTTP header, query string, etc. So this is ninth point is done. Suppose I will repeat one more time. Routing traffic based on target group. Application load balancer listening on port target group forward traffic to ECS Fargate appropriate container. This is container nothing but microservices monolithic application available. So next point, 10th point here. Then we need to understand how many ways we can access our Spring Boot app on AWS. How many ways, how many ways can we access our Spring Boot application on AWS? This is important. How many ways? How many ways can we access our Spring Boot application on AWS? How many ways can we access our Spring Boot application on AWS? Here there are different types are there. Public IP address. We can access by using public IP address. Here access Spring Boot application via public IP. B. This one I will show right now. So I will open my AWS account. I will try to access. So region is important. Like you were created AWS ECS in one region and you are searching in another region, then it will not appear. You will think you are created one. Suppose example like easy to install, but that is automatically deleted. No, that is not automatically deleted. This region is changed. This region is changed. That's why that is not available. Remember, if you are created any service, that is not available. If you think like that is automatically deleted, no, it will not happen. Region is different. So because of region is different, you are unable to see that. So tasks, this is public IP, right? Copy, open the Postman. So open the Postman. Here, how many ways can we access our Spring Boot application on AWS? So we need to know how many ways we can access our Spring Boot application on AWS. It is important to know how many ways we can access. So I created one collection. In this collection, I added two requests. This is the post request. This is get request. See, localhost is there, right? I'm changing. Currently, my container port is 8080. See, 8080. I am sending. Here we got greetings sent successfully. So get method. So port is missing here, 8080. Send. So control Z, localhost, change to IP address, send. Here we got the response, date, everything. So this application I am developed in previous videos. Like these are the two previous videos. How to manually deploy a Spring Boot application on AWS ECS using a Dockerfile and AWS ECR. It is a CI/CD manually. After that same video, some code I am deployed, step-by-step guide, push Docker images to AWS ECR and deploy Spring Boot app on AWS ECS. These two videos links I will provide in description of this video. So here we are successfully accessed right by using public IP. So how many ways can we access our Spring Boot application on AWS? We can access by using public IP. This is the one. Second one, DNS name. We can access by using DNS name. In this video, I will show how to access by using DNS name. DNS nothing but domain name system. DNS nothing but domain name system. Access applications, either Spring Boot, Python, like Angular, React, etc. Access apps, applications using application load balancer, or network load balancer, DNS names, DNS name. By using DNS name, we can by using application load balancer DNS name or network load balancer DNS name, we can access our applications. In this video, we are using network load balancer. Remember, in this video, we are using network load balancer. Third one, custom domain. Custom domain. Custom domain. Here I will provide example as well. So copy this same example. I was creating the example. This is the example. Same example copy. DNS. While using DNS, we are listening to 80, right? Port number. So it will be not there. These are the not there. Something, some URL will be appear. This is like a DNS. So no need to add colon 80, colon 8080 other port numbers. Port numbers are option here, colon 8081 like that. It is not required. So by defaultly HTTP running an 80 port number, right? Same port number we will configure at application load balancer level. So third one, custom domain. Third one is custom domain. Configure a custom domain. Configure a custom domain with route 53 or DNS services for EC2 or ALB. Here configure a custom domain with route 53 or DNS services for. So custom domain is nothing but like www.abc.com like that. Custom domain, configure a custom domain with route 53. Route 53, right? Nothing but we are getting incoming request from like www.com, right? That we need to configure at route 53. It is a domain register. After that, it is a domain register. So custom domain, configure a custom domain with route 53 or DNS services for. So in these two services, EC2 instance or application load balancer, network load balancer, DNS will be available. Domain name system, by using we can access our applications. The AWS API, gateway, expose REST APIs through AWS API gateway. For this example, here http://www.abc.com. So domain mapping, configure a custom domain with route 53 or DNS services for EC2 or application load balancer. AWS API gateway. API gateway also exposes one endpoint, right? Like this application load balancer, we can able to configure with AWS API gateway. In next video, I will show how to configure application load balancer with AWS application gateway. It will write on HTTPS. So some like HTTPS colon. Suppose this is a, you can mention like test colon abc.com. This is a gateway written the HTTPS. Suppose www.test.abc.com. Test is a versioning at API gateway level. So these are the done. How many ways can we access our Spring Boot application on AWS? This is the important. How many ways can we access our Spring Boot application on AWS? By using public IP, we can accessing Spring Boot application via public IP. Possible. DNS name, nothing but domain name system. Access applications using application load balancer or network load balancer, DNS name. So custom domain, configure a custom domain with route 53 or DNS services for ECS to or application load balancer. We can also possible to configure route 50 through API gateway like custom domain. Here also one custom domain option will be there. After that, we need to validate this. Here we are registering one domain, right? That domain we need to validate by using ACM certification through custom domain at API gateway. AWS API gateway, expose REST APIs through API, AWS API gateway. AWS gateway return gives the HTTPS URL, right? So I'm repeating one more time. How many ways can we access our Spring Boot application on AWS? Like by using public IP, DNS, custom domains, AWS gateway URL, like this. Next point, 11th point. So 11th point. Yeah, now we are accessed our application through this public IP, right? We are accessed through public IP, right? Instead of public IP, by using application load balancer or network load balancer, we can access through DNS, domain name system. Here in AWS, application load balancer, DNS nothing but domain name, domain name system allows allows clients to access your load balancers load balancer via domain name instead of public IP. See, in AWS, application load balancer DNS domain name system allows clients to access your load balancer via domain name instead of public IP. Public IP every time, every deployment, it will be changed, right? But domain name, it will not change. It will not change. It is a fixed URL. Like here, look like this is like a domain name. Up to this is a domain name. It will give up to .com. This is the domain name. Next point. So I will once repeat these are points, then I will draw a diagrammatic. I will draw and I will explain one microservices use case. Through three microservices, I will explain. Once I will repeat these points. These are the important points. Load balancing, route incoming traffic to appropriate microservices are monolithic applications. What is load balancing? Route traffic to appropriate applications is nothing but load balancing. Types of load balancers in AWS. Application load balancer used for routing HTTP/HTTP as traffic with content-based routing. If it is microservices application, it is if more than one application is there, then content-based routing required. Otherwise, we can route traffic by using single target group. If multiple microservices are there, then each microservice we need one target group and one path pattern, nothing but content-based routing. Application load balancer support HTTP/HTTPS. So example HTTP ://IP some port number student/all. So in application load balancer level, we are using here application load balancer. See, it is a 80 is a target group port number. This is the path pattern like student. If you want to, after the student, you can add void call symbol star means any pattern like after the all, save, edit, update, anything. Network load balancer used for handling TCP/UDP traffic with high performance and low latency. So in this application, we are using application load balancer. After that, gateway load balancer used for interacting with third-party virtual appliances with a transparent gateway. Classic load balancer, it is old one. Nowadays, no one is using. So this option is not available at the easy to load balancers. So I'm not discussing application load balancer in this video. I will use application load balancer. So I will start the once I will start practical, then I will show. In this video only, I will start the practicals. AWS application load balancer. Here, AWS application load balancer routes incoming traffic to the appropriate ECS Fargate containers. This is important. AWS application load balancer routes incoming traffic to the appropriate ECS target containers. Containers nothing but microservices are monolithic application. If single container, assume like a monolithic application based on target groups are routing rules. Routing rules also nothing but conditions, etc. So it will route the traffic from application load balancer to ALB to appropriate microservice. One of the routing rules is nothing but path pattern. Routing rules conditions. Here, these are the routing rules and conditions using ALB target group. If it is single microservice, then we can use single target group to route the traffic from application load balancer to appropriate easy to forget container. So application load balancer routes traffic ECS service task configured as target group, right? If single application, then create one target group without any path patterns. If you want to use path patterns also, you can use if single application, then sufficient by using port, container port, it will route the traffic to appropriate microservice. Routing rules with listener rules, listener rules, condition, both are these are the same. And target groups in routing rules with listener rules conditions, we will do like path pattern, host address, like we need to configure along with target groups. Here, routing rules with listener rules, conditions, and target groups, microservices. If we are using microservices, then we need to use multiple target groups along with conditions and along with some rules, routing rules, application, load balancer, routes traffic based on target groups along with host name, comma, URL paths using listener rules, etc. Each microservice create one target group along with conditions. Conditions nothing but I'm explaining here. Routing rules, conditions nothing but target group plus conditions. Here routing rules, conditions, these are the conditions. Host header, like it will check this header is matching or not, path is matching or not. Host header, path, HTTP request method, source IP, HTTP headers, query string, these are the conditions or routing rules or listener rules. So 6 point, the default ports for HTTP and HTTPS. This is important. The default ports for HTTP and HTTPS are, for HTTP default port is 80 and HTTPS default port is 443. Remember, HTTP default port is 80, HTTPS default port is 443. Port mapping is nothing but, so our Spring Boot application running on 8080, right? So it is a default Tomcat port number, right? So we are port mapper to container. So we are pushing our application to Docker. After that, we want to access our application while Docker run. Then we need to port our application port mapper to container port. So we need to map, right, our application port to container map. We are port mapping to container port colon Spring Boot application port. Say, for example, Docker run -d detached mode, -d nothing but detached mode. It will run on background -p. This is the container port. This container is running on AWS is here. Fargate is nothing but running container. It is a serverless computing. This is the application port. So if you are running any Docker image, then we need to mention these three parts. Username. Username is mandatory. If it is free, it is the Docker given image, then username is optional. It will directly search docker.io without if you are not mentioning username slash this is the Docker image name colon this is the tag. So routing traffic based on target group. Routing traffic based on target group. If it is single microservice, this is best choice without using any path parameters. So we can directly route the traffic from load balancer is listening 80 to target group 8080. Here application load balancer listening on port colon target group forwards traffic to ECS Fargate appropriate container. This is container, nothing but microservice or monolithic application available in container. In container, monolithic or microservice application available. So here routing traffic based on target group. Application load balancer listening on port 80 colon target group forward traffic to ECS Fargate appropriate container. This is container, nothing but microservice, or it is running microservice or monolithic application in container, either microservice independent service or monolithic or microservice or monolithic application will be available. Example, this is a application load balancer port 80. This is the container port. This is the application load balancer port. This is the container port. If multiple microservices are there, then we need to create multiple target groups or single target group also fine. Then you can separate by using path pattern. Either suppose node if multiple microservices are there, then create different target groups or your single target group, but provide multiple roles. Roles is nothing but path patterns. Path patterns. I can say you can use, if three microservices are there, use three target groups and add three path pattern. Suppose 80801, 80801, 80801. This is one target group. You can provide this port. Another for 8081. Another target group. Another target group like third one 8082. Plus path pattern. You can provide path pattern. Otherwise, you can use only. You can create one single target group and provide different path pattern by using path patterns. You can add multiple roles. So I'm repeating 9 point. Routing traffic based on target group. Routing traffic based on target group. Application load balancer listening on port colon target group forward traffic to ECS Fargate appropriate container, which is container nothing but microservices. Container nothing but in container we will store independent microservices are each container we can store one microservice or one monolithic application. So example, this is the 8080 application load balancer port. It is running on HTTP. After that, this is the target group. If a if single service is there, then create one single target group. It is sufficient. But with multiple target groups are, if multiple applications are there, independent services are there, then create multiple target groups with each target group have a separate port number. Then you can mention the path patterns. If these path patterns also not sufficient, so it is like a creating duplication like that. Then you can use headers, query parameters like that. See, we have different types are there, right? Post headers, path, HTTP request method, source IP, HTTP headers, query string. These you can use. So one by one I can explain. Each one I can create a one video. After that, ninth was done. How many ways can we access our Spring Boot application on AWS? We need to know how many ways can we access our Spring Boot application on AWS. This we should know. By using public IP, we can access our DNS name, domain name system, we can access, and custom domain. By using custom domain, we can access this custom domain registered at the Road 53. Or if custom domain is available, like your GoDaddy, your registered one domain, those domains also we can access here. So otherwise, the fourth one, AWS API gateway. If so in AWS ECS service, we have deployed one application, right? It is running on Fargate as a container. It is running. So we are now decided to route the traffic from application load balancer to AWS ECR Fargate service. So we are connecting with application load balancer. So this application load balancer DNS we can able to connect with gateway. So right, gateway will provide HTTPS endpoint. So AWS API gateway expose REST APIs. So we can create in API gateway REST APIs through AWS API gateway. In AWS application load balancer DNS domain name system allows clients to access our load balancer via domain name instead of public IP. As of now, we are accessing our Spring Boot application by using public IP, right? So we can also access by using DNS domain name system. So we can access by using DNS domain name system, right? So after that, now I will explain one use case. So here I will explain one use case. For that, I will open Paint. So I will open the Paint. Suppose this is a load balancer. These are the three microservices. This is microservice 1. This is microservice 2. This is the microservice 3. So I will enter here container ports 8080. This is running on 8080. This is running on 8081. This is running on 8082. I have three microservices. These are running on AWS ECS. Each microservice contains different port numbers. These are the container port numbers. Do one. I can also add application port numbers. Suppose colon 8080. So these are the application port numbers colon 8080 colon 8080. These are the three microservices. Three microservices. I build a Docker image. After that, I push it to AWS ECR Elastic Container Registry. These three applications are running on 8080, but we are container port. We are giving 8080, 8081, 8082. So I want to connect with, like I want to distribute traffic based on target group one path pattern. So this one I will add user as well. Browser, suppose browser from browser. This is the application load balancer. Application load balancer. This is a application load balancer. So from browser, request is coming through port 80. So incoming request is coming to application load balancer. This application load balancer route the traffic to appropriate microservice based on here target group. Target group. Suppose this target group is a port number is a target group port number is a 8080 plus path path pattern. Suppose example this is a user microservice. This is a customer microservice. This is a storage microservice. So here now it will route the traffic by using 8080. It is a target group. This is the container port, comma, suppose slash API slash user. This is the Spring Boot application controller path. Based on these two, it will route the traffic. So in this application, this topic will be this path will be available based on the port and this based on the port and path pattern. It will route the traffic. Suppose here also API slash customer. Here also API slash student. So based on the target group path pattern, it will route the traffic to appropriate microservice. Here 8080 comma slash API slash customer slash star. This is the target group. This is the path pattern, right? So same here also. It is a 8081. It is a 8081. Right. Now here target group, comma, target group plus path pattern. Path pattern. Based on target group and path pattern, it will route the traffic. Again here also 8082. It is a target group, comma, path pattern slash API slash student slash star. It is a path pattern. This is the target group. This is a path pattern based on the target group plus you can also put comma plus something. Path pattern based on path pattern. It is route the traffic to appropriate microservice. So request is coming to the browser via 80 port number, listening port number via browser application load balancer listening on port 80 by using target group and path pattern. It will route the traffic to appropriate microservice. So this is done, right? One theory point is there about. So let's add theory point. Suppose one theory point is there. To route traffic to three microservices using a single AWS application load balancer. This load balancer running on port 80, running on port 80. You can configure the application load balancer with different target groups for each microservice for each microservice, each listening on a different each listening on a different port like one microservice is listening on 8080, another one 8081, another one 8082. So this is done. Third point here, to route traffic to three microservices via a single AWS application load balancer on port 8080. You can configure the application load balancer with different target groups for each microservice. Each microservice is listening on a different port. So another point, the routing decision are based on path based or host based rules. which are configured at the application load balancer level. So here to route traffic to three microservices using a single AWS application load balancer on port 80. You can configure the application load balancer with different target groups. Each listening on a port, different port. Each microservice can listen on different microservice. So if three microservices are there, then we need to create three target groups. The routing decision are based on the path based. We need to each microservice has a one target group, and we need to mention path. This routing decision based on path host related rules, which are configured at the application load balancer level. In the listeners, we need to configure these. Here, they are the routing rules there, right? Routing rules. We need to create each microservice as a one target group. After that, we need to create one. We need to choose one. Most of the company choose path-based routing. Okay. So it is done. These are the important points about application load balancer. So coming to this is the diagram. These are the two videos are there. These are the two videos, right? How to manually deploy a Spring Boot application on AWS ECS using a Dockerfile and ACR. Step-by-step guide, push Docker image to AWS ECR and deploy Spring Boot application on AWS ECS. So this is the architecture for these two videos. I will quickly recall once. By using Spring Initializer, I generated welcome app. After that, I am imported into IntelliJ IDEA. In IntelliJ IDEA, I am created two Spring Boot controller endpoints. See, these are the two endpoints, greetings endpoints and retrieves endpoint. So after that, I'm created on Docker file. In Dockerfile, I am added few comments like from command. Here, from command, it will be base image. What directory it is. In container, it will create one folder. Copy command in target. One jar file will be available. The jar file will be copied to container. This is the our Spring Boot application port we are exposing. This is the entry point, nothing but we are running the jar file by the JavaScript -jar. This is jar file name. This is done, right? After development is done, we are executing the Maven code like clean install. It will generate jar file. After generation jar file is generated, we will start the Docker desktop. Once Docker desktop is up and running by using AWS security credentials, interact with AWS. We will interact by using AWS like access key, secret key region. We can access to AWS via AWS CLI. So after successfully we are interacted with AWS, we need to log into ECR. After that, we need to tag nothing but when you are creating Docker image. After that, we need to build. So we need to create a Docker image. After that, we need to push to AWS ECR, right? Prerequisites are like you need one AWS account, Java must be installed, Maven must be installed, Docker desktop must be installed, AWS CLI must be installed, IntelliJ IDEA must be installed, Postman must be installed. These are the prerequisites for previous video. Now current video, I will explain. These are the while creating the AWS ECR. I am added. So access key and secret key were created to access, were generated to access, were communicate through AWS CLI to AWS. After that, we are created on security group. We are added inbound role like custom TCP. It is port 8080 to access our application, our container port 8080. Like I am giving permission. If any request is coming through 8080 port, please allow. Like it is a allowing some permission. Add IAM rules like this rule is nothing but to give some permission to ECS service. Like you can deploy this Docker image to AWS Fargate service. This is permission. So after that, it is this image. After successfully posted, it is storing into AWS ECR. So this AWS ECR will provide image URL by using that image URL. So in task definitions, we need to mention while creating the container name, port mapping. This URL we need to mention. So these task definitions will manage it by service. Service manages task, scaling, load balance, IAM role, allowing inbound traffic. Here nothing but inbound roles. So after that, by using public IP, we are accessed this Spring Boot application, right? Public IP and port. So these are the discussed in these two videos up to. So in this video, here post in this video, prerequisites are so at application load balancer, we are exposing to another port, right? We are exposing to 80 port. So this is old one, I think close. This is the new one. See, create security group, add inbound roles, custom TCP 80. So now we are accessing through 80 port number. Then we need to add one inbound role. So let's do that. We need to add one inbound role. Let's check where it is security groups, networking, here networking. Do one go to cluster. After that, go to service. Now check in service available or not. In service, task definition is there. We need to find the click on tasks, scroll down. So let's go to network tab. See, this is the security group, ECS, some security group I'm created. If you are using all TCP, then any port it will allow. I don't want to allow all ports, so I want to allow one specific port, 80 port. So inbound roles, edit inbound roles. So these are there, right? So custom TCP, these are the two added. Okay, I will keep it. Custom TCP, 80 port, anywhere IPVP. So save rules. So we are successfully saved rules. Here prerequisites are were completed. Go to some changes where I am done. See, I will explain. This is the IntelliJ idea. Suppose by using Spring Initializer, I am generated Spring Boot application. After that, imported IntelliJ idea. I am created one some developed some Spring Boot code and added Docker file. After that, after the successfully code developed, I then Maven clean install. It will generate jar file. The jar file once that generated the jar file, I am started Docker file. Docker desktop. I am started Docker desktop. After that, in AWS, I'm created access key and secret key. By using those access key, secret key and region, I'm connected into AWS. After that, connected, I am logging into ECR. I push the Docker image to AWS ACS. ACS is nothing but image store. So by using image URL, so task definition, we are linked image to task definition. This task definition managed by service. Service manages task scaling, role balancing, public IP, allowing inbound traffic. Here we are added 80, 80, 80, 80. These are the two inbound roles. See, so I am expanded this three microservices. So single application load balancer listening on 80, three microservices running on different port numbers, different same Spring Boot port numbers, but different container port numbers. We are accessing through target groups and path patterns. Path patterns, right? These are three containers about three microservices. These three microservices, Spring Boot applications are running on same port number, but containers running on different port numbers. 8081 container, 8082 container, 8083 container, right? So see, this is elastic container service. It is also like a orchestrator. So we are accessing via this is the load balancer. We are accessing via load balancer. At load balancer level, we have the DNS available, right? Domain name system. See, route traffic based on listener port. Listener port is nothing but HTTP default port is a 80. I am using same. After that, target port. See here, listener port 80, target port 808 star means 123. Based on this are URL path based slash API slash welcome star. If microservices we are deployed in easier, then we need to use both target groups and path patterns. Both we need to use. So some request we are getting from the either some browser, some user we are getting like phone, desktop, something we are getting incoming traffic via 80 port number. So it will be receiving to listening to application load balancer based on target group port and path pattern. It will reach to appropriate microservice, right? See here, so in AWS, ECS is nothing but manages or orchestrator. It will manage services, task definitions, right? So cluster is nothing but it will groups services and task definitions, right? Three microservices are there. Each microservice have one task definition, one service. We can use single cluster or multiple clusters. I will tell that also. Like are these three containers, right? These containers are running on AWS Fargate. AWS Fargate what this will do? It will run containers. Each Spring Boot application have one task definition, one service. These are grouping, cluster grouping, task definitions, services, right? So let's have 2 points about cluster. When we choose one cluster, when we need to choose multiple clusters. So use single ECS cluster. Use single ECS cluster. Best for cost, best for cost, efficiency, best for cost efficiency, shared resources, and simpler management, simpler management. See, when we need to choose single cluster, see now we are using single cluster. This is the single cluster, right? When we need to choose single cluster, best for cost efficiency. If you feel more charges are charging AWS, then you can use single cluster, share resources, and simpler management. So if you want to manage easily, then we can use single cluster. When we need to choose use separate cluster for clusters, separate clusters. Like we have three microservices are there, that microservice 1, microservice 2, microservice 3. Then when we choose each microservice as a one cluster, so I am telling choose use separate clusters, better for strict strict isolation, better for strict isolation, scaling or security needs, security needs. Here when we need to choose single cluster, this is single cluster we are using right now, right? So I'm telling use single ECS cluster, best for cost efficiency, comma, shared resources, comma, and simpler management. For this we need to go for single cluster. Use separate clusters, better for strict isolation. Use separate clusters, better for strict isolation, scaling, or security needs. If more security is most important for each microservice, more strict isolation, scaling, like that, then we need to go for separate clusters for each microservice. So here by using target group and path pattern, see route traffic based on listener port colon target group, based on the container port and path pattern. It will route the traffic to appropriate microservice. This is the application load balancer is there. See application load balancer, it is running on port number 80. Application load balancer is there, it is running on port number 80, based on target group nothing but some ports are there. Some port, each microservice have a one target group port number and path pattern are headers are request query parameters are request params are, based on those it will route the traffic to application load balancer to appropriate microservice, right? By using DNS, domain name system. What is DNS? DNS is nothing but domain name system. Here it is important, so I am reporting. So it is a AWS ECS. It is a orchestrator. This orchestrator will manage clusters, AWS Fargate services, task definitions. So these every container will run on AWS Fargate, right? In task definitions, containers, images are we are creating and port mapping. These task definitions are managed by services. Task definition, container specification, container is nothing but like images are there, container and port mapping available. Services manages task scaling, load balancing, right? This public IP also available at service. In service, we need to allow inbound traffic. So just now we have created 80 custom TCP, right? So in service, load balancer option is there. This I will create one load balancer. I will attach to this service. Then this drop by using we can access by using target group and path pattern. We can access to appropriate microservice. Share or to access appropriate microservice by using application load balancer. Route traffic based on listener port. Listener port is nothing but 80. It will route the traffic. Target port is nothing but every microservice application running on one port, right? Like 8081, 8082, 8083. So based on that port plus URL path based on port and path. So it will route to appropriate microservice. Suppose single service is there. It is suppose it is a monolithic application is there. Then we can route the traffic by using target group. We can route by using target group without using path patterns. So right request coming from the browser, it will goes to application load balancer. Request coming from the browser via 80 port number. So based on the target group and path pattern, it will route the appropriate microservice. So it will do some operations. It will run this microservice. Again, it will return response to application load balancer. This application load balancer will give response to browser. This is done, right? So I will scroll down. This is the entire here. This is the entire diagrammatic representation. So here this is entire diagrammatic representation. Right? Minor changes I done here. This is the load balancer. I added application load balancer. Here I will repeat one more time. Request coming from the browser. It will reach to application load balancer ALB. Right? Via 80 port number. That application load balancer is listening on 80 port number. Based on the target group, port and path pattern, it will route to appropriate microservice. So request coming from the browser, it will request coming from the browser, application load balancer listening on 80. Once request is reached to application load balancer, based on the target group and URL path, it will route the appropriate microservice. See, it will route the appropriate microservice. Here, this entire diagram, I am moving. See, request coming from the browser, it will so application load balancer listening. If any incoming traffic is coming through browser, based on the target port and path pattern. See, here in Postman, this is the 80, it is a port. This is the pattern, path pattern, based on the target group, port number, target group is nothing but port numbers we are stored, and path, it will route to appropriate microservice. It will route to appropriate microservice based on the target group and path pattern. It will route the appropriate microservice, right? So we are understand, right? Request coming from the browser. So application load balancer listening at port number 80. If any incoming traffic is coming from the browser, it will coming to application load balancer. Based on the target group and path pattern, it will route to appropriate microservice. So application load balancer listening on port 80. If any incoming traffic is coming to application load balancer, it will route the traffic to appropriate microservice based on target group and path pattern. That's it. So create one load balancer. Load balancer are available and easy to service, like Elastic Container Service. First create a target group. So as of now we have deployed only single microservice, right? Welcome app. So I will create one target group. I will show also if multiple microservices are there. Go to create target group. Go to add path pattern. So they are the target groups. Create target group. IP address. Don't select instances if you are using AWS ECS Elastic Container Service. Forget AWS ECS Service or forget both the same. If you are using, then choose IP address. Remember, must choose IP address. Suppose target group, I am mentioning like a welcome hyphen app. Welcome app target group. See HTTP port number, container listening on port number 8080, right? So I'm not changing anything. Let's check. First, we have selected IP address. Easy to see this AWS Elastic Container Service. If we are by using application load balancer, if you want to connect to AWS ECS service, then choose IP address. If you want to connect AWS application load balancer to ECS Elastic Container Service, then choose IP address. ECS service nothing but you are connecting to service. Forget these any, you can choose IP address. In service only load balancer option will be there. Name of the target group, port HTTP only. It is running on HTTP only my application. This is the 8080 container port. This is the container port. Application port mapped to container port. Via container port we are accessing. Now we are mapping container port to load balancer port, right? Then if any else check your endpoints are there in your application, like else kind of, you can mention. I don't have any else check endpoints, so I am not mentioning. Next, networking. Remove this. This is not required. No changes. Create target group. See, we are creating the target group. Welcome app target group. So see, load balancers non-associated. Then create one load balancer. Load balancers. See, there is no load balancer. Create These are the three types of load balancers: application load balancer, network load balancer, gateway load balancer. Application load balancer works with HTTP, HTTPS. HTTP default port is 80, HTTPS default port is 443. This will work through the TCP UDP, right? Choose a network load balancer when you need ultra high performance TLS, offloading at scale, centralized certificate deployment, supports for UDP, comma, and static IP address for like that. You can choose a gateway load balancer when you need a deploy and manage a fleet of third-party virtual appliances. So I am choosing. So my application is Spring Boot application like HTTP, right? HTTPS, right? So I am choosing this create. I'm choosing application load balancer. It is asking load balancer name. Welcome app application load balancer. Internet facing internal. See, schema cannot be changed after the load balancer is created. If you want to change this to this, it is not possible once it is created. Then we need to delete and we need to create new one. This select the see where name is entered. After that, VPC I am not changing. Default one. Available regions I am selecting all three. After that, security group I am selecting. This is I added at 804. I am selecting default I am removing. Listeners and routing. Listener is nothing but application load balancer port routing. It is a Spring Boot application container port. See, it is a HTTP default port. I am not changing. So here I am changing. We have created one target group. This target group running on 8080. So I am not changing anything. Create load balancer. This is for the monolithic application. After that, I will show for microservice application as well. It is one successfully deployed. Go to Elastic Container Service. So now what I done? So I have a load balancer, application load balancer by using target group. I created, I added in application load balancer, target group added. In this video, I'm not using like now, currently I'm not using path parameter, path parameter. After that, once this is completed, I will show what to use path parameter. Like let's try to, this is service, right? Let's try to update. In service only load balancer option will be there, but it is not giving load balancer. So do one thing, welcome app service, right? Welcome app service, delete this one, post delete it. Welcome app service, remember, successfully deleted. So create one. So task definition, we need to select revision latest, select service name is welcome app service, replica desired. If you want to increase, else same. Deployment options, failures, these are not changing. We need to networking. In networking, let's check is there any target groups. Use an existing one, select existing one. This is easiest. This one, select. After that, close this one. Load balancing. This is important. We are linking AWS ECS to application load balancer. Select application load balancer. Create new. We are created, right? So choose application load balancer. This is application load balancer. Yeah, check grace period. If you want to add, suppose seconds it is saying. So suppose 10 seconds I'm mentioning. Listener, listener. I'm saying use existing one. This is the listener. So okay. See role path. I'm not passed anything. Just I'm created one target group by using 8080 port, right? Create new target group. Target group. I'm using existing one. We are using, right? This is target group 8080 port. Yeah, I'll check. I'm not mentioning. No endpoints are available in my application for health check. So created the cloud configuration exists, same service name. So it is saying it is not allowed. Let's see what will happen. It will be created. Otherwise, I will change name. It is saying that service name is already available. So it is not allowing. Let's check. Then do one thing. Change the service name. Service name I am giving welcome app service. Welcome app. Welcome app. iPhone. Spring Boot. welcome app -, Spring Boot. So close this one. Let's create. It is saying that service is already available. So just now we are deleted that service. That's why it is saying. See, now that error we are not getting. Welcome -, app Spring Boot deployment is in progress. So go to refresh here. Deployment will be this. See, post it will be red color. Don't feel like it is not working. Don't feel like it will be changed to green. After 1 minute, it will be changed to green. See here, colors are changed. It will be changed to green. Once it is deployment, it will be like completed. Then this deployment successfully completed by using application load balancer DNS domain name system. We can access this application. In this application, two endpoints are there, right? This is the send greetings endpoint, retrieve greetings endpoint. Two endpoints are there. Refresh. It will take around 3 minutes to complete. So wait some time. If you want to use in cloud configuration, what are the steps involved to create? Then you can observe the logs. These are some events here. Triggering the events here. Conjure V2 service something. Some events will be triggering. 3 events is triggered. These are the events. If you want to repress it, okay, I'm closing. If you want to observe it, let's I'm refreshing this one. Deployment is going on. See, green color. Once it is completed, then we can access our application through DNS domain name server. Meanwhile, I will repeat one more time. So this application load balancer listening on port 80, right? If any incoming traffic is coming to this application load balancer, it will route the appropriate microservice based on based on target group. Target group is nothing but each microservice have one target group. In target group, we are adding one port number target group, and if multiple services are there, then we need to route traffic by using target group and path. Path we need to add multiple listener roles, or we need to add roles, multiple roles. So we need to add multiple roles, right? Based on path pattern. Multiple microservices are there. I have only welcome app, so I'm not adding right now. But I will show once this deployment is done, I'm able to access this application. Then I will show how to add path patterns. If multiple microservices are there, then how to do like this application load balancer setup, how to integrate with application load balancer with AWS ECS. So here deployment has green color. We need to last deployment needs to be completed. Then only we can access our application. Until it may it will take few minutes to like 1-2 minutes only. It will be take to complete this. Then I will open the load balancer. Then I will copy DNS by using DNS. See, while creating application load balancer, we are added 804 port, right? 804 port, and we are selected one target group. Why we are using path pattern? We have target groups there, right? We can create multiple target groups. We can link each target group with one AWS application load balancer. If you like, I have 3 microservices. If you want to go with 3 application load balancer, it is okay, fine. Without path pattern, we can do. But this is the most cost efficient. Like with single application load balancer, if you want to route the traffic to multiple microservices, then we need multiple target groups, and we need to add multiple roles by using the path pattern, headers, host headers, like that source IP. Then we need to route the traffic to appropriate microservice as per our requirements here. Target group, and these many are there. Host header, path, HTTP request method, source IP, headers, query string. In this video, I will cover this. In this video, I will cover this. See, it is not still not deployment, not done. So wait some time. If you want to see again, cloud configuration, cloud formation. So I'm closing. Scroll down. Here, go to task. See 4 minutes. Let's check. Scroll down. Go to welcome. This is the app cluster. Deployment. This is the service. Still it is running. So click on service name. So here deployments. See, one failed, one completed. Else check where selected, right? This is the application load balancer port. This is the our application port. This is the listening port. This is the target port. If it is failed to deploy, failed to this service creation is failed. If failed, then I will re recreate other service, right? So it is taking more time. Let's wait. In progress. Wait some time. Deployment it will try 3 times. It is failed 3 times. Then it will service will be failed. Let's go to service. Scroll down. Refresh. Last video I created that time this much not taken. It is taking more time now. Let's wait some time. It is last deployment in progress. Either it will be completed or it will be failed. It will be failed. Then we need to again create the service. That's it. Let's check the cloud formation. What are the events it will be triggered? Let's explore what are the options are there. 3 events are there. So it is creation in progress, deletion in progress, something is going on. So go to close this one. So service not yet created, it is still in progress. So one task is running. Click on service name to failed. That means this service is not working. Let's wait, it will be failed another time and it will be service creation will be failed. Then wait some time, the service will be failed. After that, I will delete the service and I will create new service with different name. So 2 deployments are failed. Third deployment is trying. By defaultly, it is set to three deployments. If 3 deployments are failed, then this service creation will be failed. So once it will be failed, then I will create again. See, it is taking more time. Deployment not yet done. See cloud formation. Some events are there, right? Assume these are logs. See, welcome app cluster. Cluster is created. Welcome cluster, welcome something. It is failed to delete. Conjure. It is service, new service, right? Welcome app, Spring Boot welcome. This is trying to create. Let's see if it is successfully created, then our application created. No issues. It is failed, then we can just delete this one. We can create again. Here again, it's showing tasks. First time when I will start, it is saying like already exists, right? Those processes are done background. So now it is creating our service. It will creating. It will take some time. This time it will take more time. So it is working. If it is deployed, okay. Yes, then I can delete and I can recreate. So in this service only we are adding load balancers. Here it is failed. So if it is failed, then we got another chance to create it, right? So if it is failed, then we got another chance to create it. So don't feel like it is failed. No, no. If it is failed, then we got another chance to create it, right? This is the welcome app cluster. Create this name. This time take unique names. No changes. Family. This one. Suppose this. You can give welcome hyphen app hyphen with ALB. I'm not changing anything. Networking. Networking M. This is the security group. Security group we are created. This one select. After that close this one. Go to load balancer. choose application load balancer, same previously. See here, container. See container, this is a 8080 is a application port mapped to container port. Right? This is welcome app container. So application load balancer existing, just now we are created. Application load balancer, all checks don't select, we are added, then this time don't enter anything, leave it as default. This is the application load balancer listening port. See, this is the target group. This is listening port. Target group we are added 8080. Path we are not specified. If you want, I will show to edit it. Use an existing target group. So existing target group. This one only I'm selecting. L check. If any L check path is there, you can select. So after that, create. So create. It will again try 3 times. It is success. If success, it will be success at first attempt only. It will be failed. Then it will be failed after third attempt. 3 attempts it will do. Let's check what will happen. It will not take more than 2 minutes. If any errors are there, like if anything went wrong, then it will take 4 5 minutes time definitely. Otherwise, it will done 3 minutes itself. These are the previous ones. So this is the new one. This is the new one. These are the previous ones. So these are the three steps type kind of refresh. Go to, let's go this. Wait some 2 minutes. Then after then we can check deployment. It is a success or failed. See task running one. Let's verify as well. Cloud formation. Some events will be triggered. 3 are there. Creation in progress, creation in progress, creation in progress. So wait something. Let's see what will happen. See 2 by 1 task running. We can also check like here. This is service name, right? Click this service name. Here deployments two completed. Two completed. It will do 3 deployments. So I think this time will be success. So because first time we are given same name, right? So it is giving issue. That's why it is failed. This time it will definitely pass. It will be successfully deployed. If any errors are coming again, then we can create another time. Another time we will check load balancer configuration as well. I think this is correct. It will be completed. Let's see what will happen. Now 1 by 1 task running. It will take around 3 to 4 minutes. Sometimes it will take 7 8 minutes as well. Mostly 3 to 4 minutes it will take. So one task is running. Refresh. Refresh. Once successfully deployed, then I will open the EZ2. In EZ2 application load balancers are there, right? I will go to application load balancer and I will copy the DNS name. DNS is available there, like some HTTP colon, some .com is there, some correct, after that .com. So again, go to deployment service name. Say current state, one failed, one completed. So this time also maybe failed. Let's check what will happen. You close this one, go to services. So let's check deployment. Refresh. Go to service. Wait some time. I'm passing meanwhile this video. Let's see. This is the service name. 2 failures. I don't think it will work. Let's delete this one, force delete, delete. So go to load balancers. I will delete also load balancer target groups. Then I will create new one. So delete load balancer, confirm, confirm, go to target groups, select, delete. So it is done, right? Create new target group, IP based. After that, target group name. Give the V hyphen target group port number. This is the our microservice or monolithic application port. Health check. So I don't have any health check. This is not there. I am not added any health checks. Next, select the. This is remove. Create target group. Once created, go to load balancers. Create application load balancer. It will support for HTTP, HTTPS. Create. After that, WE hyphen application load balancer. Internet facing. Once it is created, not editable. So remember that availability zones, whatever availability zones available, select those. Security groups. Security group select. So we have created this one. ECS. Default one I am removing. Listener is nothing but application load balancer port 80. This is a microservice port. Here only one target group option will be there. We can also create a target group here. Only option one target group only we can select. That's why we need to add router rules to communicate with multiple microservices. If it is multiple options are there, then we can select, we can add multiple target group. Then whatever request is coming to application load balancer, it will route by using port. That option is not there here. So remaining are I'm not changing, create. Check load balancer successfully created. So go to Elastic Container Service. Cluster will be there. There are no services. So better to delete these as well. Is there any delete option? Not there. Okay, go to cluster. So task definition side, this service right. Create. We need to select task definition. After that, revision. Latest I'm choosing service name. W hyphen service. So number of tasks to run. Only one subscription. Networking. In networking, we need to select existing only. This one. Next. Public IP, I am not turn off. Close this one. Load balancing. Application load balancer. This is the application port, container port. Use existing load balancer. Choose existing load balancer. Health checks I am not mentioning. Create new listener. We have already existing listener. That is sufficient. Here this is the target group based on the this is the VTG means this is target group. If any request is coming to 80, it will route this target group. I am not selected any path. So existing target group one I am selecting. See, specify whether to create a new target group or choose existing one. That load balancer will use to route request to the tasks in your service. Existing one is this target group one I want to route. Yeah, I'll check HTTP. I'm not changing anything. Same previous settings only. Let's see what will happen. If it is created, it will take 2 minutes to create. Otherwise, it will also again fail. First, it will be look like only red color only. After it will be changed. So if you want to open cloud formation, See, these are the three. So let's check what will happen. Deployments, tasks, one by one, task is running. Sometimes it will be failed, it will unable to create the resources. So see one by one task running. It will take exactly 3 minutes. If it will take more than 3 minutes, then it will be failed. You can assume like it is failed. Say it is failed. Let's go to service, click on service name. Deployment current state, 3 failed. So go to 3 service, click on here. Circuit breaker task failed to start. So why? Do one thing, delete entire cluster and recreate. So delete cluster. Control V, delete. I think some memory is like that. Let's check what will happen again. Close. So here clusters are not there. Create cluster. I'm giving like a cluster, well cluster. No more. Create it. Let's check in cloud formation. What will happen? 5 events are there. Configuration completed. Configuration completed. Okay. This is the ready. C region UI syst -1. We are using. Just refresh it. See, this is the well cluster. Wait some time. It will still take. Yeah, now it is completed. So just refresh it. Fine. Click on it. Create service. Specify the. This is the task definition. Service name give well service. Network groups. Use existing one only. This one. Load balancing. Choose application load balancer. Application load balancer. This is the container mapping. Spring Boot port. This is container port. Use an existing. Then scroll down. Existing one only. Listener. This is the target group also existing. So if you want to add health check, like you can mention. I don't have any health check. So hence I'm not changing. Create it. Just refresh. Post will be red color. After it will change into